Hi everyone. It's me again. Yeah, it's been a while. So yeah, about last week. First of all, sorry I didn't post anything. I will say I'm okay. A few people expressed concerns, having not heard from me um, about my health, but I'm okay, which is a good thing. Um, Everyone here is healthy. No one's sick. My wife did get tested for coronavirus, but luckily it came back negative. Um, I just had a rough week last week, and I've been struggling with kind of finding the time to do these lessons with you all. Um, so I apologize, but I will try to keep things going. And luckily, I was able to finish this lesson now for this week. Um, and I'll try to plan for the next like 4 or 5 weeks. I think we've got 6 weeks of school left, and I think we're going to close out this unit today on exponentials, um, and then we'll move on to kind of our last unit for the year, and I'll try to give you guys a review of, not a review, but a basic overview of trigonometry, which is a really important subject that is going to be kind of a necessary requirement for next year if you're going on to pre-calc. That being said, I'm going to try to keep this video as short as I can, so I'm going to try to go through this lesson with you. I've created a lesson in Desmos here called Introduction to Logarithms. We're going to learn about what is a logarithm. What does that even mean? So I'll go ahead and hit go. And don't worry, this is not as tricky as it sounds. It's kind of a weird word, but something you don't hear every day. First thing I'm going to ask you to do is kind of just check in here. Make a sketch. Draw a sketch of your energy level over the last couple of weeks. So I would say for me, it's definitely fluctuated. Go ahead and draw what you feel like here. Mine's been kind of up and down a little bit. Feeling a little bit better today. Um, Having a hard time, a rough time with all of the social isolation and sort of taking care of my family. My bedtime has definitely been pushed back. Getting later. And mornings have been. That's how I've been doing lately. And again, I apologize for not getting this out sooner. I hope you're all doing well, by the way. If you ever feel like kind of, you know, the isolation is getting to you, talk to somebody, talk to a friend, get outside. It's a beautiful day. Um, Make sure that you are taking care of yourself and your mental health. Okay, so here's our first question for math question here. Unknown exponents. What value of x would make each of these equations true? Write your answers below. So, well, let's see. We've got three equations. 2 to the x equals 4. What would make that true? Well, 2 to the 2 equals 4, right? Yeah, that's 1. Oh, I might need to change the way that this works. Give me 1 second here. Okay, so, sorry about that. Hold on a sec. Okay, so let's see. I think I've fixed this, so I can write maybe in some math here. 2 to the 2 equals 4. So our first answer is going to be 2. Right, so x equals 2. What about the next one? 2 to what power equals 16? Okay, well, think about this for a second. Try this on your own. I should have asked you to pause it. Try to answer if you can answer these other two questions. 2 to what power is equal to 16. Oh my god, I gotta turn these notifications off. Hold on a sec. All right, so 2 to what power is equal to 16? Okay, so well, let's see. 2 times 2 is 4. 2 times 2 is 8. Times 2 is 16. So it looks like 2, 2, 2. You need four twos. So if we were going to write this, we would say 2 to the 4 oops, equals 16. So the next answer is that the exponent would have to be 4. Ooh, man. Now we've got a big number, right? 1024. And that's a tough one. I mean, you could write it out. I challenge you to figure it, write it out, get a piece of paper, and multiply it, 2 times 2 times 2, see how many times you need to do it to get to 1024. For me, I'll say the last one is pretty difficult. Sure. You could do it. Let me also, I'm not sure off the top of my head. And again, some of your classmates should their answers should show up here. So this is the idea. How do we find these unknown exponents in these equations? Here's another unknown exponent. What value of x would make 2 to the x, 2 to that number equal 3? Take a minute, take a moment, pause the video and think about it, and then write down your thoughts in this box below. Okay, so hopefully you've taken some time to try this. And the first thing you should notice is that 3 is not a power of 2, right? 3 is not a power of 2. Right? 2 is a power of 2, 4 is a power of 2, and it's somewhere in the middle. It's not so x isn't a whole number. It's not an integer. What could we say about x? Well, 2 to the 1 is 2, right? Um, but let me see. Get some math here. 2 to the power of 1 equals 2. And what else do we know? 2 to the power of 2 equals 4. So it's probably, if the answer we're looking for is is 3, is somewhere between 2 and 4, then this number, the exponent, must be somewhere between 1 and 2. So x must be between 1 and 2. I don't know what it is though. It could be 1.5. It could be 1.7 or 1.8. I'm not really sure what it is. And this is another question. So like these questions in the previous screen, we could kind of figure out what x would have to be, what the exponent would have to be. And this one, even though I didn't personally want to do it, you could do it. You could figure it out. This is a power of 2. In this equation, this is not even a power of 2. So figuring out what x would have to be would be even more difficult. And what we're going to look at today is how to actually figure that value out. Let's try looking at a graph first. So here's the graph of y equals 2 to the x. It's an exponential curve. Drag the point to the place that would approximate the value of x that makes it equal to 3. Makes 2 to the x equal 3, true. Write that approximate value below. So go ahead, take a minute. I'll pause the screen again and see if you can figure out what this x would have to be. Remember we said it was probably between 1 and 2. I'll pause the video, try it out. Okay, so let me go in here. So let's see. When is the y equals 2 to the x? When is y going to be 3? Well, it looks like the y value of 3 is somewhere around here, close to 1.6 maybe. Let's see, can I get any closer? Not really. It's close to 1.6. X equals about 1.6. So 2 to the 1.6, we could check it with a calculator here. We could also check this. Maybe I'll have to move myself over. Myself over here for now. 2 to the power of 1.6. Yeah, it gets us pretty close to 3. And it's not exact, but it's close. Based on this graph, it looks like x would have to be about 1.6. So here's a bunch of exponential functions. These are what we call exponential functions because they involve some kind of base raised to a power of x, to a variable. And this is the general form for an exponential function. So you put in, how does a function work, right? You put in a value for x, you get a value for y. That's a typical function. When we're trying to solve an equation like this, 2 to the x equals 3, we're asking a different question. We're not asking, for what, if we plug in a number for x, what do we get out? In this scenario, what do we ask? What are we given? We're given the output, and we're trying to find the input to the function that gets us that output, right? So we've given the output. We know the output and are trying to figure out the value of input x. So it's a different question. Instead of, it's kind of like reversing the idea of a function. And I know we kind of maybe not didn't talk about that. We should have this year. But that's what we're trying to do. We're trying to figure out what's the input that we need to get to 3. And that idea is actually called the inverse of a function. The inverse of a function says, in order to get this output, what do we need the input to be? So it kind of does the reverse. It says, we know the output, what's the input supposed to be? And now we're getting to the idea of what a logarithm is. A logarithm, which is kind of, I know it's a weird word, try practicing it with your, saying it. There, we do abbreviate that. We just say, we call them logs, because logarithm is a little long to say. But logs are the inverses of exponential functions. So here's y equals 2 to the x, the same function we saw. And then if I press on this circle, y equals the log, and I'll explain this a little bit better. I know it looks funky right now. There's like a little 2 at the bottom. The log base 2 of x is the inverse of this function. What does that mean? Well, what value does the blue graph give you when x equals 3? Let's see. If we set this equal to where x is equal to 3, can I get close enough to it? There we go. X is equal to 3 in our blue inverse function. Our output is 1.585. 1.585. Let me put that on the graph. 3 comma 1.585. And I can even make this, I can make it blue so it shows up on the blue side. So what does that mean? That means that, remember, our inverse function was saying this is the output we wanted, and it's going to give us the input. So that's the value x that we needed to make y here 3. I know this is a little, conceptually tricky, but we could test it. So now we've got a better value here. Instead of 1.6, 1.585 is based on this log function. And again, I could test it. Let's try 2 to the 1.585. That gets us really close to 3 as our output. So the value is 1.585. What x has to be equal to looks funky, in our exponential function. Okay, so that was a graph. Here's a good idea, the definition of a logarithm. A logarithm is a function that tells you what the exponent needs to be in a given exponential equation. So it's when we don't know, when the exponent is unknown. So for example, these two expressions are interchangeable. Or we could use this example. 2 to the 3 equals 8 is an exponential equation, and it's equivalent to saying that 3, the exponent, is log base 2. Logs have a base, just like an exponent has a base and a power. Logs have a base too. And the base here is the same as the base in our exponent, in our exponential equation. And what it gives us is what the exponent needs to be. So it's a little tricky. Try take some time, pause this and take a look at these two things. But that's what a log is. A log has a base, and it tells us the power that we're looking for. Here's another look at a logarithm. And this is how I typically remember it. It's called the spiral method. To help you remember what the definition of a logarithm is, think about this. What this is saying is that b, the base of the logarithm, to the power of what's over here is equal to x. So if we look at this example, what this is saying is 2 to the power of 3 equals 8. So if you're ever confused, this is how I kind of remember how to read logarithms. And then we'll get some practice and try to sort this out. But this is a good way to remember it. So here's a bunch of pairs of exponents or exponential functions and logarithms, exponential equations and logarithmic equations. See if you can match them up. I'll pause the video and see if you can figure that out.